Hello students and welcome to Unit 7 Part 1 Lesson 3. In this lesson we will learn to interpret solutions to systems of linear equations. Our first and only essential question today is, what does the solution to a system of linear equations mean in context to a real-world problem? But before we start, I have a really special message for you, and I want you to make sure that you read it and understand it and really take it to heart. Okay, here it is. What's wrong? You don't know what it says? You don't know the meaning of it? Well, what if I told you that it's really a cryptogram and every letter that I wrote is really the letter after it? So for example, I wrote a T, that's really a U. I wrote an M, that's really an N. A C is a D is an E, a Q is an R is an S, and an S is a T. A Z is an A, because we're going back to the beginning of the alphabet. M is an N, C is a D, H is an I, just going with the letter after what I wrote. M is an N, F is a G. H is an I, R is an S, H is an I, L is an M, O is a P, N is an O, Q is an R, S is a T, Z is an A, M is an N, and S is a T. For you see, understanding is important. And if you don't know how to interpret a message, you didn't know that I was really writing the letter before what I meant, then you had no understanding of my message. Similarly, a solution with no meaning is useless. In this lesson, we're going to explore how to make sense of solutions to systems of linear equations. So to interpret solutions to systems of linear equations, there are two steps. First, identify the solution. Find the solution on the graph, find the solution in the problem. You're going to also learn in part 2 how to find that solution using elimination and substitution, but for now we're just going to look at graphing, or I'm going to give it to you. And then secondly, describe what that ordered pair means in context to the situation. A very helpful hint is to use the x-axis and y-axis to help you determine meaning, because they will be labeled with what x stands for and what y stands for. So it's very similar to when you are interpreting intercepts, where they cross the x and the y-axis. So let's look at our first example. Jimmy Sports Apparel sells all of their hats for $15.95. The cost to produce one hat is $10.95 plus a one-time fixed cost of $75. The revenue or income received by selling hats versus the cost of producing hats is represented on the graph below. What does the solution to the system below represent? So I see on our graph we have a red line, which represents the cost of the hats, what it costs to manufacture them. So for example, when they sell no hats, they still have $75 in making them, because there was that fixed rate. And every hat that they may have them purchase adds an additional $10.95 in cost on to the bill. Now the revenue is what they sell the hats for, so this green line is what they sell the hats for. So you can see that here at 5, if they sell 5 hats, they're actually making less than what they paid for 5 hats. The cost to buy 5 hats for the store is more than what it costs when you buy 5 hats as a customer. So let's find our solution. Our solution is here where they cross. And this would be the point. We just come down our x-axis, 15, and go across to our y-axis, 240. Now remember, this is an ordered pair, x, comma, y. So we can look to the x-axis and y-axis for the meaning of 15 and 240. So 15 is our X value, so that's the quantity of hats. So 15 hats. And 240 is our Y value, which is our price in dollars. So this is $240. Now, we just don't want to write 15 hats costs $240. Even though that's true, we need to relate it back to both the cost and the revenue. So when they're both the same, that means that it costs Jimmy $240 to buy 15 hats, but when he sells the hats, 15 hats also sell for $240. This is the point where Jimmy breaks even. He's not losing money, but he's not making money. So let's try to describe that in a complete sentence. So the solution, 15, 240, means that it costs Jimmy $240 to buy 15 hats, but it also means he can sell 15 hats for the same amount. This is Jimmy's breaking even situation. This is where he's not making money, but he's not losing money. Everything after this, he's making money. Everything before this, he's losing money. Let's look at another situation. The cost to rent and view movies online is $2 a month plus $2 per movie. So that's Y equals 2X plus 2. To rent a movie and receive it in the mail is $6 a month plus $1 per movie. So Y equals X plus 6. The cost of the two movie rentals are shown in the graph below. Interpret the solution to the system. So we can see that the red line or the solid line represents online movies. And we could also tell, if it didn't give us this key, by the fact that the y-intercept of the online movies starts at 2. Okay? We can see that y equals x plus 6 has an intercept of 6, so this is the line for the movies in the mail. Now, the solution is going to be where they cross. Well, they cross at 4, 10. Remember, this is x comma y. So the x value of 4 means 4 movies, and 10 is the y value, which is the monthly cost. So $10. Now, we cannot just say 4 movies cost $10, but we have to relate it back to both online and mail-based movie purchases. So, what this means is, for both the online and mail options for viewing movies, four movies costs the same amount, and that amount is $10. Now, this is also interesting because now you can see that it would be cheaper if you plan to watch 5 movies to get movies from the mail. But if you plan to watch less than 4 movies, it would be cheaper to watch them online. Two texting options for a phone are available for a limited number of customers. The first plan has an $80 deposit, so I know that's going to be our y-intercept. So this is the one we're talking about. This is first plan. But has a low monthly cost of $10 per month for unlimited texting. So that's y equals 10x plus 80. Goes up 10 every month. The second plan has a $20 deposit but costs $30 a month for unlimited texting. So that would be down here. It starts at 20 but then it goes up $30 every month. The cost of the two plans are shown in the graph below. Interpret the solution to the system. Well, the solution is going to be where they cross, which is right about here. Now I can tell that it's on the number 3, but I'm not really sure about this output, so I'm going to substitute 3 in here. 10 times 3 is 30 plus 80, that's 110. Yeah, that makes sense because it's in between 100 and 120. So 3, 110. So we have this solution, 3, 110. 3 is the x value, 110 is the y value. So the x stands for months, so that's 3 months. And the 110 is the y, so that's cost in dollars. So that's $110. Now, we're talking about cost here, and we're talking that both of them meet at 3 months and $110. So for both plans, 3 months will cost $110. So we're going to restate that as for both plans, 3 months of texting will cost $110. Now you can also see that if you plan to have texting for less than 3 months, the second plan would be cheaper. But if you plan to text for more than 3 months, the first plan would be cheaper. Tom's Candy Store has an income of $20,000 every 3 months. So y equals 20,000x. So you can see his income is the solid line. Goes up 20,000 every 3 months. Up another 20,000 every 3 months. Okay, so that's this line. Expenses include 30,000 once a year plus 10,000 every 3 months. Y equals 10,000x plus 30,000. The relationship is graphed below. Interpret the solution to the system. So you can see that this is what it costs to keep Tom's Candy Store running, purchasing new candy, bills, etc. So you can see that right here is the solution to this system. This is 960,000. So 9 is our x value, so that's 9 months. And 60,000 is monthly amount, so that's dollars. Okay? Now remember, we have to compare this order pair in relation to both income and expenses. So what this order pair means in terms of income and expenses is that after 9 months, Tom will earn an income of $60,000 from his candy store, but he will also spend $60,000 during that time as well. So, at 9 months, Tom will earn $60,000 from candy sales, but will also spend $60,000 in expenses.